All right, now we're going to factor quartic functions, but before we do that, we're going to recall and try to remember our factoring of quadratics, because you're going to find that it's the same process, the same type of factoring. All right, so the first type of factoring with quadratics was just a GCF problem. So that would look like this. If I gave you 2x squared plus 3x, you can pull out an x, so your final answer would be x, and then you have 2x plus 3. Okay? All right, another way was what, I don't know, there's no fancy name. I call it the short method, which we should be experts at now. If I said x squared plus 7x plus 12. All right, what multiplies to give you 12? That adds to give you 7, 3, and 4. So here we go, x plus 3, x plus 4. Okay? And then the last one, some of you do slide and divide. I teach factor by grouping, and you're about to find out why I teach factor by grouping. So if I gave you 2x squared plus x minus 10. All right, if this was one way you were not very good at before, I suggest you really take note of it, because we're going to add on to this in this unit. All right, so I asked myself, just in my head, I take 2 and I multiply it by negative 10, and I get negative 20. And then I'm going to ask, okay, what multiplies to give me negative 20 that adds to give me this positive 1 right here? And that's going to be negative 4 and positive 5. So I'm going to rewrite, just rewrite, not change anything, rewrite this x plus 1 term using minus 4 and 5, because that's what they add up to be. So minus 4x plus 5x minus 10. Again, I didn't change the value of my quadratic, I just changed what it looked like, because if you simplified those middle two terms, you would get 1x. All right, so factor by grouping, you need at least, well, you need 4 terms to factor by grouping, so I'm going to separate into 2. The point is that you separate them so that now you can take a GCF out of each binomial separately. So our GCF for the first one is going to be 2x, and I'm left with x minus 4. And then my GCF in the second one is going to be 5. Oh, I'm not left with x minus 4. I'm left with x minus 2. There we go. Sorry about that. And then I'm going to have x minus 2. So I knew I caught my mistake, because these two have to be equal for it to be able to be factored this way. So then your final answer is x minus 2. And then you take the 2x and the plus 5 and you make that your second binomial. So there we go. That's your final answer. Okay, so now we're going to factor quartic functions. Okay, quartic. So 4th degree. So we're going to factor the same 3 ways. We're going to factor it with GCF, the short method, and then by grouping. All right, so if I gave you x to the 4th plus 3x squared, you would see that there's a GCF of x squared, and you can pull it out. And this would be your final answer. All right, then this one we're going to do the short method. So you might want to make note of that on your paper. So it's the same concept as before. So I can even start and go like this. All right, what multiplies to give me negative 24 that adds to give me positive 2? So those two numbers are going to be positive 6 right here and minus 4. But here's the thing. What is going to go right here and right here? What do you think goes there so that my first term is x to the 4th? All right, did you think that it'd be x squared? Well, it is. So the short method is the same way that we did short method with quadratics, but now it's just a quartic. So you take x squared times x squared, and you're going to get x to the 4th. And then when you add x squared times that negative 4 and then x squared times 6, you're going to get 2x to the 2nd. All right, and then let's look at the last possible way and why I taught you to do factor by grouping. So if I gave you 6x to the 4th plus 11x squared minus 2, what multiplies to give you negative 12 that adds to give you positive 11? Well, that's going to be 12 and negative 1. So I write 6x to the fourth plus 12x plus negative 1x minus 2. I'm going to group them together. My GCF in the first one is 6x. Oh, I messed up. I forgot to put 2. Sorry about that. So that means that this is actually, I can take out a 6x squared. All right, then left over, I'm going to have x to the second plus 2. And then I hope I get x to the second plus 2 in the second part. And I will if I factor out a negative 1. And I get x to the second plus 2. So since these are the same, that's my first factor. And then my other factor comes from my GCFs, 6x squared minus 1. And there we go, we're finished. Now, the reason why I teach factor by grouping is because I could give you a problem that just starts out with 4 terms, maybe not 3 like this one. So let's take a look at that example. All right, so we're no longer assigning it just a quartic function. So quartic functions, and actually all even degree functions, follow that same method of solving like we did, factoring like we did with quadratics. But now you can factor by grouping with any degree. So here's a 6th degree polynomial that I'm going to ask you to factor. All right, you see 4 terms. You should know, all right, now I can group. The GCF in the first one, x to the fourth. Left over, you're going to have x to the second plus 2. The GCF in the second one is going to be actually a negative 16, and I'm going to be left with x to the second plus 2, which is what we want. Those are the same, x squared plus 2, x to the fourth minus 16. Now, here's the trick. You're not quite done yet. Because if you notice, this guy right here is the difference of 2 squares, so we can continue to factor. So this is going to be x squared plus 4, x squared minus 4. And then we have x squared plus 2. Well, we're still not finished, and that's because right here we have the difference of squares again. All right, so I'm going to erase from the top so that we can keep everything on the same page. All right, so my final answer is going to be x squared plus 2. You can't factor this down anymore. It's not the difference of 2 squares. 2 is not a perfect square, and it's not a difference. Same thing with this one, 4 and a plus. And then over here, you're going to have x plus 2, x minus 2. So this is our final answer. I know that was a long problem, but it started just by factor by grouping. And then the difference of 2 squares kind of came out. So we're going to factor all the way down every single time that we can. All right, let's look at one more example like this. All right, so this is factor by grouping. Why don't you pause the video and try it yourself. All right, I'm going to go ahead and group. Now, I need to change this into plus and minus right there, okay, because I need that plus sign. Please don't get rid of the addition or subtraction sign, because then you guys are going to think to multiply, which I don't want you to do. The GCF in the first one is x squared, and I'm left with x plus 3. Over here in the second one, it's going to be negative 4, and I'm left with x plus 3. So my answer is x squared minus 4 and x plus 3, and I hope that you see this right here. Difference of 2 squares. X plus 4, x minus 4. And then you bring down the x plus 3. So the other way you can check yourself is say, okay, well I have an x, and then if I multiplied it 3 times, I'm going to get a cubic, which is which we started with. So factor by grouping can be any degree. Any degree. All right, so there's one more thing I just want to go through with you. I want to go back to factoring, and we kind of call this the quadratic method. If I gave this one, this is the one I gave you before. what multiplies to give you 12 that adds to give you 7, right? Okay, so and then I showed you one with a quartic. Well, if you notice that one with a quartic, let's just use the same numbers. Say it was x to the fourth plus 7x squared plus 12. So then I had x squared plus 3, x squared plus 4. Same numbers, it's just instead of x plus 3, it's x squared plus 3. Well, the same concept I could have also given you x to the 6th plus 7x to the 3rd plus 12. So this would have turned into x to the 3rd plus 3, x to the 3rd plus 4. And the pattern would continue. So when you factor a quadratic way, it doesn't have to be a quadratic, but a quadratic way, what has to happen is this value right here, it has to be even, okay? Because this degree on your middle term is half of your the first term degree. For example, what I'm trying to say is this is 2, half of 2 is 1. This is 4, half of 4 is 2. This is 6, half of 6 is 3. So I could have even had x to the 10th plus 7x to the what though? What would that have to be for us to factor the same way? 5. It has to be half. So that is a stipulation for this type of factoring, but again, it doesn't have to be a quadratic or a quartic. It could be any of these values for the degree.